All right, 4.2 is logarithmic functions. Let me see where we start. Let's look at our definition. All right, so definition here for when x is positive, b is positive, and also b is not equal to 1. We have y equal to, this is log base b of x, and that's also equivalent to b to the y power equal to x. And then here it says the function f of x is equal to log b of x is the logarithmic function with base b, which is what I just mentioned. So let's see if I have, oh, as a matter of fact, I'll do this one. All right, so y equal to log base b of x. This is your base, and this is your exponent. In your exponential form, this is still your base, and this is still your exponent. So those relationships hold true. And b is always going to be your base no matter what relationship you're using. B is always your base. All right, so we're going to write this in exponential form. We have 2 log base 5 of x. So first of all, you can start off by writing your base. You know that your base is the 5. And the way I look at the relationship is whatever's next to the base in one relationship should not be next to the base in the other relationship. So you notice when you look at the log here, what was next to the b is x, but then when you go down here, what's next to b as your exponent is your y. So it would be the other number. So here I have 2 is equal to log base 5 of x. So the 2 should be my exponent of the base, and then x will be on the other side by itself. For the next one, log base 3 of 7 equal to y. Same thing here, write down your base first, which is 3. The 7 is next to the 3 in the log relationship. So in the exponent relationship, it should be the y that's next to the 3. And then the 7 is on the other side by itself. One more. Next one, 3 is equal to log base a of 64. A is the base, 3 will be the exponent, and then 64 will be on by itself. So next, we're going to write in log form. Take the same thought process. So log base 12, because the 12 is the base. That will be applied to x, and the 2 will be on the other side by itself. So once again, what is next to the 12 in the first relationship should not be next to the 12 in the second relationship. So here is b cubed equal to 8, so this would be log base b of 8 is equal to 3. And here, log base e of 9 is equal to y. All right, questions on those before we go to the next one? See if I can write that one better. All right, so general properties. Log base, log with the base of anything being applied to 1 is equal to 0. So if you apply the log to 1, the result is going to be 0. Log base b of b will be equal to 1. Log base b of b to the x is equal to x. Basically, you drop the b and you're left with the exponent. And that's a variation or an extension of rule 2 because your exponent here is 1. And so that's what's here. That's what's left is that one. Same thing here. Your exponent is x, and what's left is the x. So you have the same base being applied to that number. If you have a base being applied to that same number, I should say, the exponent is what would be left. And then this log base b of x, that is the exponent. And notice the bases are the same here. And then what would be left is just the x, what the law is being applied to. All right, so just quick examples of that. Log base 5 of 1 is going to be 0. Log base 7 of 7 is going to be 1. Log base 4 of 4 to the 5th power is just going to be 5. So what we're saying is that, this part, because they have the same bases being applied to each other, will cancel out and just leave you with the 5. And then here, 8 to the log base 8 of 9 is going to be left with you'll be left with just 9. And same thing happened. That this part pretty much cancels out. You just left with the 9 that the law was being applied to. All right. Questions on that before we look at same properties but applied to some specific logs. All right, so the first law that you should be made aware of is your common law. It's log base 10. In your calculator, when you don't see anything, they assume you know that there is a 10 there. So log base 10 of x is the same thing as log of x. So if you don't see anything there, then you should assume that there's a 10 there. All right. And of course, this is they bring these up because these are the ones. This one should see in your calculator. So the same four properties with respect to the common log, log base 10. All right. And the next one, all right, so here we have the natural log, that's log base E, and this is the other log that is in your calculator. Now and I will say this, some people have the calculators that have this as an option, where you can put whatever base you want down there. So a lot of calculators don't have that though, but what they do have in the calculator, the natural log and the common log. So ln is the natural log, and so they always want you to know that that means that's log base E. And then let's look at all four properties. Look at all four properties with the natural log in mind. All right. So properties, same four properties, just that with respect to the natural log. Natural log 1 is 0, natural log of e is 1, natural log of e to the x is x, and then e to the natural log of x is x. All right, so let's simplify a few. Well, that's pretty much it. Well, I guess this would be good enough. Trying to see if I could find any other good ones, but they're pretty much doing the same thing. So simplifying, here we have log of 100. Don't forget that log, if you don't see anything, they assume you know that's base 10. So it's best to turn this 100 into 10 squared. And then so log base 10 applied to 10 squared will just cancel out and leave you with 2. So this right here will cancel because of your base 10. Same thing happens in the next one. We have 10 raised to the log of 33, and you're just left with 33 because of that relationship will cancel. Here, if you were to rewrite this one as e to the negative 6 power, that will give you the relationship that you need in order to be able to cancel out this part. And that will leave you with just negative 6. And then this last one, that cancels out to give you 75. I could leave it like that. Let's do this log. All right, so if we look at this, we have log base 3 of log base 7 of 7. So of course you do what's inside of your parentheses first. Log base 7 of 7 is just going to be 1. And then log base 3 of 1 is just 0. All right, any log applied to 1 is 0. All right, so in this next one, we're looking at log base 2 of 32. Notice we're not really trying to pull out a calculator. We're trying to see if we can do it without a calculator. And so when I look at 32, if I want to look at it in terms of 2, because I have this base 2 here, that's 2 to the 5th power. So I can rewrite that 32 as 2 to the 5th power. So now this log base 2 of 2 to the 5th power will reduce down to 5. And then log base 5 of 5 is a positive 1. All right. Questions on anything, any of that? And that's it for 4-2. If you're calculating. let's see. So today is, that's right. Next week we won't have class. Okay, so let's start on 4.3. All right, so here we have properties of logarithms. We have the three rules: product rule, quotient rule, and the power rule. So we have log base b of m times n. We can expand that out to be log base b of m plus log base b of n. They equal to the same thing. Or we have log base b of m divided by n. So log base b of m minus log base b of n. So that's the numerator minus the denominator. And then the power rule, log base b of m to the r. If I have m being raised to a power, I can bring that power down front. And then that'll be r times log base b of m. All right, so if we want to use the first rule, the power rule, to expand, that's log base 4 of 35. I can look at that 35 as 7 times 5. There's no other way to break up 35, excuse me, other than into those two prime numbers. And if that's the case, I can break it up to log base 4 of 7 plus log base 4 of 5. Same thing here. Now I can break up that 10 into 2 times 5, but if I'm looking at breaking up our numbers or our terms so that I can reduce as much as possible, don't forget that my base right here is 10. So I will break this up into log of 10 plus log of x. in which log of 10 we talked about already is 1, and then I will leave that log of x as is. All right, here we have log base 7 of 19 over x. So it's log base 7 of 19 minus log base 7 of x. All right, same thing for the next one. Natural log of e to the third minus natural log of 7. But once again, we have to recognize that base that we have here. That's base e. So natural log of e to the third is just going to be 3. And that minus natural log of 7 stays in the back. All right, any questions so far? All right, so here if we just want to use the power rule, that 4 will come down front. So that'll be 4 log base 5 of 7. And that's all we can do there. And that last one, natural log of the square root of x, we recognize that the square root as an exponent is 1/2. Bring the 1/2 down front, so it's 1/2 natural log of x. All right, any questions on any of those before we add a little more to it? All right, here we have log base a of x squared times square root of y. So the first thing we recognize is that we have x squared times square root of y. So it's multiplication. That means we'll be expanding it out by using addition. If it was division, then we would be subtracting. So it's log base a of x squared plus log base a of the square root of y. So my exponent here for that square root is 1/2, like I mentioned before. And to use the power rule, we take all of our, or each one of our exponents and put it up front. So it's going to be 2 log base a of x plus 1/2 log base a of y. And that's your answer. All right, so here we have log base 6 of the cube root of x divided by 36y to the 4th. So because we have division, that's going to be subtraction. That will allow us to break it up. So we're starting off with log base 6 of the cube root of 1/3, cube root of x, excuse me, and log minus log base 6 of 36y to the 4th. Now notice that our denominator can be broken up into two terms, 36 and y to the 4th, and the reason why we look at that is because of this base of 6. And if that's the case, just remember that anything that was in your denominator should have the minus sign in front of it. You know, if you were to put parentheses around that and start to expand that, do your plus and all that stuff like that, ultimately what's going to happen is that whatever's in your denominator has the minus sign in front of it. So before we, instead of adding all the minor details, just keep that in mind. If it's in your denominator, it should have the minus sign in front of it. So when I break this up here, this will be log base 6. I'm going to go ahead and write that as x to the 1/3 minus log base 6 of 36 minus log base 6 of y to the 4th. All right, reason why I did that is because it's log base 6, x to the 1/3. Log base 6 and 36 is 6 squared. I can write that 36 is 6 squared. So that helps me in reference to my base. And the log base 6 of y to the 4th. So now to finish it off, take my 1/3, put it out front. This simplifies to just 2. And then I'll take this 4, bring it down front as well. So it's going to be 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. All right. Questions? All right. Any questions? So we will look at condensing now and then stop. That'll be a good place to stop. And we can finish off 4-3. Well, there's only one more thing for 4-3. So we can finish off 4-3 today. So I take that back. We'll finish off 4-3 today. All right, so next we're looking at writing as a single log. So instead of expanding, we're going to condense. our expressions. So we're going to work in reverse. And remember, this doesn't work if our bases aren't the same. So we have log base 4 of 2 plus log base 4 of 32. All right. So remember, if it's addition, that means I can rewrite it as multiplication. So I can rewrite this as log base 4 of 2 times 32. So that would be log base 4 of 64. That's important to us because 64 is 4 cubed. Log base 4 of 4 cubed is 3. All right. Let's do this. Put a 2 out front. All right, so here we have 2 log of 4x minus 3 minus log x, or log of x. First thing I can recognize is that this 2 is in front, and if I want to take it back to an exponent, I can do that. So it's going to be log of 4x minus 3 squared minus log of x. Now that minus sign says that I can turn it back to division. So that's log 4x minus 3 squared divided by x. All right, let's do at least one more like this. All right, so we have 4 log base a of x minus 2 log base a of 7 minus 1/2 log base a of y. All right, so just like before, first thing I would do is look to bring or to take each one of my exponents back to where they should be. So it's going to be log base a of x to the 4th minus log base a of 7 squared minus log base a of y to the 1/2. All right, recognize that we have minus signs here. So that means both of them should be in our denominator. Remember what I mentioned about that? Also, we have 7 squared, which would be 49. So I want to bring those together. It's going to be log base a x to the 4th minus log base a of 49 y to the 1/2. right, so now to finish it off, this is log base A, x to the fourth over 49, y to the 1/2. Or log base A, x to the fourth, 49, square root of y. Either one is fine. All right, any questions before we look at the last thing out of this section? All right, so how do I do that? What did I do here? This should be a B. Right. Okay, so you change your base property. So if you have a calculator that has this option where you can put any base down here, then you don't really need to change your base property. But some calculators only have the common log and the natural log in it. And so you would need to change your base property if your base is something other than 10 or E. And so this will help you to calculate something that has a base, calculate a log that has a base other than 10 or E. So we can use either the common log of M over the common log of B. Notice your base is in the denominator. No matter what relationship you use, your base is in the denominator, and then the other numbers in your numerator. So common log of M over the common log of B, or the natural log of M over the natural log of B will still give you the same result. So we'll look at how that works. So let's say if the direction said find all right, so if we want to find log base 5 of 140, we can either do log of 10 over log 5, or we can do natural log. I said 10, it should be 140. All right, so going at the calculator. 2.14. In the chat. Are we allowed to use a calculator for the section on the final? Oh no, you can use your calculator. Yep. Most definitely you can use your calculator. I think that'd be jacked up for me to show you a way to do it with your calculator and then be like, nah, y'all can't use it though. So no, you most definitely can use your calculator. Now there would be certain things that you should be able to do without your calculator, like the log property principles that I showed you. But like stuff like this, most definitely you would use your calculator on. Yep, not a problem, not a problem. And I'm just doing this in pieces just to show you how this thing works. But you only have to do one or the other. You don't have to do both. But just showing you that either one will work fine. Probably should have made more room for myself, but it's all good. So when I do that, the approximation will be 3.07. They'll tell you how many decimal places they want from you, of course. And then we should get 3.07 in this next one as well. Yep. So either way you get, oh, sorry about that, knocked my earpiece out, but either way you'll get the 3.07. All right, questions on how you use the change of base property. And once again, just reemphasizing the fact that if you have the button on your calculator that has a little square here and a bigger square, that means they're giving you the option of putting any base in there. That means you could have just used this, the way it is, and would have got the 3.07. So it just depends on what type of calculator you have. All right. Questions on anything before we look to close out today? All right. So next class, we'll be looking at 4.4, and that section will take us into our Thanksgiving break. All right. So if you guys are good, I'm good. I will see you on next class. You guys have a good one. Have a good one.